Okay, we're going to continue this part 4 video. So here become minus 3 plus 1 over 2. This will give you a value of minus 1. Okay, and then the bigger value, the x2, the x-intercept on the larger, a bigger value is plus 3 plus 1. So it's 4 over 2 will give you 2. Okay, so therefore I can write here as minus 1, the smaller x-intercept, and then this bigger x-intercept, which is 2. Okay, so that's it. From here, your graph, by knowing the x-intercept, the two x-intercept, you're able to sketch a better curve. Okay, it will depend on the question whether it asks you to sketch the x-intercept. Okay, if there's no such need, then you don't need to find the x-intercept. But sometimes you are required to find the x-intercept. What do you mean by that? For example, d is a quadratic function. Okay, sometimes you ask the question, solve this quadratic function. It's just a quadratic function in a completing the square arrangement. Ask you to solve the equation. Okay, so to solve this equation means y, when they put here 0 means y equal to 0. So whatever value you get here, the x1, x2 is actually the x-intercept, the two x-intercept. Okay? So when you're asked to solve a quadratic function, when you put an equation where y equal to 0, whatever value you obtain from the quadratic equation for the x value is actually your x-intercept when you make y equal to 0. Okay, when you make y equal to 0, whatever x value you get, the x1 and x2 actually represent the x-intercept of the quadratic curve. Okay, now so remember, but actually you don't need to convert it into completing the square in order to find the x1 and x2. Normally in our quadratic equation, you just factorize it, put normally the right hand side of the equal sign is equal to 0, and then you have the quadratic function on the left hand side, and then on the right hand side is equal to 0. What it's saying is the y is equal to 0. Okay, for example, what I mean is like that. Let's say if I say that x squared minus 5x minus 14, actually this is equal to 1. This is a quadratic function, but this is here is not, when you say a function d is not equal to 0, but sometimes you will say could you solve a quadratic function and put y equal to 0? Okay, put y equal to 0. Okay, what's the meaning of this when you put y equal to 0? Basically, whatever value you obtain from here when you make y equal to 0, the x value they obtain, they are actually the x-intercept of the quadratic function. Okay, right? So in this case, you don't need even in a completing square format, just a normal format. As long as you factorize it correctly, minus 7 x plus 2. Okay, now what do you get here? X equal to 7 or x equal to minus 2. What it's saying is if I sketch this curve here, okay, I sketch this curve. Basically, it's a maximum. You have 7 here, then minus 2 here, and you know this is a positive coefficient for the x squared term, so it's a minimum. Okay. Now we also know that it passed through the x-intercept is minus 14. Sorry, the y-intercept is minus 14. Here, this is the y-intercept. So from there, I know the curve should be this. Okay. From here, without doing the completing the square, we cannot tell where is the what are the coordinates of the minimum point. Okay. From here, we can only tell. From here, we know the y-intercept is minus 14. And by putting y equal to 0, we are finding the x-intercept. Okay, after you obtain the x value, 7 minus 2, this actually is the x-intercept. Okay, but you couldn't find out what is the coordinates of the minimum point, except you go and reconvert this quadratic function, the standard quadratic function, into a completing the square format. In this manner, when you have converted into this manner, then you can determine the coordinate of the maximum or minimum point. Okay, but without the conversion, no doubt you can find the y-intercept, you can find the x-intercept from these two. Okay, but you can even sketch the curve without knowing the minimum point. Okay, in this case. Okay, so hope that this will be helpful for you, this piece of information.